We talked about the number of roots of a polynomial being at most the order of the polynomial. So here's one to illustrate that. This is a seventh order polynomial. And it's hard to see this polynomial because it increases and decreases so rapidly. You can see there's a root here, passes at x equals -5, at x equals -3, -2, -1, 1, 2, and 4. So that should be 7 roots. We're also interested in what do polynomials do as you look very far along the domain. What you will find is that if the polynomial has the highest order that is odd, then it will have two different parts that point in opposite directions. Let's look at an easier example. Okay, let's look at x to the 5th power. So if the highest order of the polynomial is odd, you will see this feature in the middle. You will see that it's increasing towards the origin, and then it has an inflection point. It may have some roots in here, and then as you keep going on along the domain, eventually it goes off to positive infinity. Now this is true only if the coefficient in front of x to the 5th is positive. We can change this by making it negative. Okay, so positive with an odd power, negative with an odd power. Okay, now if your polynomial is even, has an even power, you're going to see that both of the limits as you go outside from the origin go in the same direction. And this is true if the highest order of your polynomial is even. And it really, in the limit that you go all the way out on the domain in both directions, it really doesn't matter what else follows it. It's the highest order in the polynomial that will rule what the polynomial does as you go towards positive or negative infinity. So you can see that this has something, it looks a little bit like a quadratic function, but it's flat here. And both of the limits go upward. Now if we were to take a look at some polynomial, even polynomial with other terms, well, there's some local maximum and minimum, but in the end, in the limit that you go either direction to infinity, you can see that the function goes upwards on both sides. Now again, this is easy to change by changing the sign of the leading coefficient. So now the leading coefficient is negative, and we see that we just turned the graph upside down. Well, not completely. We turned the highest order part of the graph upside down. Now because this only has one term, for this one we can turn the whole graph upside down just by multiplying it by -1. Okay, so the sign makes a difference as to whether or not the function goes to negative infinity or positive infinity. And this is also really important for odd functions. So x to the 5th power, if we don't multiply it by a negative number, we see we increase from left to right. And if we put in the minus sign, we decrease from left to right.